Good morning. In previous video we have discussed matter in our surroundings, that is physical nature of matter and characteristics of particles of matter. Then in this video shall we discuss about states of matter?
Good morning. Yes, that sounds good. Today we will discuss states of matter. We'll cover the three main states, their properties, and how they differ from each other. Let's begin with solids. Do you know what makes solids unique?
Discuss with me what is that solids and liquids and gaseous states.
Excellent. Let's dive into the details. Solids, for example, have a definite shape and volume. Think of a table or a book. Their shape and volume don't change easily. Would you like to share an example of a solid?
Yes.
Great. Now let's talk about liquids. Unlike solids, liquids don't have a fixed shape, but they do have a fixed volume. They can flow and take the shape of their container. Can you give me an example of a liquid?
Water is an example of liquid.
Correct. Water is a great example. Finally, let's discuss gases. Gases have neither a definite shape nor a definite volume. They spread out to fill their container. Can you give me an example of a gas?
Air is another example of gas.
Perfect. Air is a perfect example of a gas. So, to summarize, solids have definite shape and volume, liquids have definite volume but not a definite shape, and gases have neither. Does this understanding feel clear?
Will you give some difference between these three states of matter?
Certainly. The main differences lie in their particle arrangement, shape, and volume. Would you like me to explain them one by one or compare them in a table-like format?
One by one you can explain.
Alright, let's start with the shape. Solids have a definite shape, meaning they don't change their shape unless acted upon. Liquids, however, take the shape of their container. And gases, they expand to fill the entire container they are in, so they have no definite shape. Now, do you want to discuss volume next?
Yes.
Okay, so regarding volume, solids have a definite volume. That doesn't change easily. Liquids also have a definite volume, meaning the amount of space they take up stays the same, even if you change the container. Now, as for gases, their volume isn't constant. They expand to fill the entire space they're available. Does that distinction make sense?
Yeah.
Great. To solidify your understanding, could you tell me the difference in compressibility between solids and gases?
Okay, you can explain that one.
Solids are practically incompressible, meaning their volume cannot be reduced by applying pressure. Gases, on the flip side, are highly compressible, allowing their volume to be greatly reduced. Does that make sense?
Yes.
Excellent. Now, how would you explain the difference in fluidity between liquids and gases?
Will you explain that?
Liquids and gases are both fluids, meaning they can flow and take the shape of their container. The difference lies in their resistance to flow. Liquids are generally less fluid than gases, meaning they flow more slowly. Does that make sense?
Yes.
Great. Now, let's discuss another important characteristic, density. Can you explain what density means in a context of these three states of matter?
You can explain that one also.
Generally, solids have the highest density, meaning their particles are more closely packed. Liquids have a slightly lower density, and gases have the lowest density as their particles are spread far apart. Does that make sense?
Yes.
Now, let's touch on the effect of temperature. What happens to the particles in each state of matter when you increase the temperature? Generally, when you increase the temperature, the particles in all states gain energy and move faster. In solids, they vibrate more vigorously. In liquids, they move more freely, and in gases, they move even faster and further apart. Does that make sense?
Yes.
Perfect. Now, let's consider the opposite. What happens when you decrease the temperature? How does that affect the particles in each state? When you decrease the temperature, the particles slow down and lose energy. This causes the particles to come closer together. For example, a gas will condense into a liquid and a liquid will freeze into a solid. Would you like me to elaborate on this process?
Yes.
As the temperature decreases, the particles move more slowly and come closer. This causes the substance to change from gaseous to liquid and then to solid. Would you like to know about the melting and boiling points as well?
Yes.
Melting point is the temperature at which a solid becomes a liquid, and boiling point is the temperature at which a liquid becomes a gas. Would you like to know more about these?
Okay, you can explain those.
Sure. The melting point is the temperature at which a solid becomes a liquid, and the boiling point is the temperature at a liquid becomes a gas. These temperatures are specific to each substance. Would you like to know any other details?
Okay, thank you. We can discuss further in next video.
You are very welcome. We can definitely discuss further in the next class. Is there anything specific you would like to prepare for our next topic?
Can you prepare about can matter changing its state? In next video we can discuss that one also.
That's a great idea. We can definitely discuss how matter can change its state, exploring concepts like melting, boiling, freezing, condensation, and sublimation. I encourage you to look up these terms beforehand. Is there anything else you'd like to cover?
Okay, we can discuss in next video. Thank you. Bye bye.
You're very welcome. Have a great day and see you next time.